Hello, let's continue our Sudoku adventure with Aztec Polka Dance by Emphyrio. So we have normal irregular Sudoku rules. So that means in every row, every column, and every bold outline region, we are placing the digits 1 to 6 exactly once each. So instead of our normal 2x3 boxes, we just have these bold outline regions. So this is a region, this is a region, this is a region. They're all size 6 and there's 6 of them, just like boxes. So we're placing 1 to 6 in each. Every cell is part of a region. All right, we also have these black and white dots called kropki. And so white dots separate consecutive digits. So if this was a 2, this could be 1, because 1 is consecutive with 2, or 3, because 3 is consecutive with 2. The order doesn't matter. And black dots separate digits with a 1 to 2 ratio, meaning 1 is double the other. So if this was a 2, this could be 1, because 2 is double 1, or it could be 4, because 4 is double 2. Not all the dots are necessarily given, meaning if this was 2, 4, there's no black dot between them, but that's okay. We haven't been given every black dot, so this is legal. That's specified because in standard kropki, which is a separate pencil puzzle from Sudoku, this has been incorporated into Sudoku quite frequently, but in standard kropki, all the dots are given. So you can assume that if there's no black dot, then you can't put 2, 4 across it, for example, across these two cells. But in this case, we are not giving all the dots. All right. So those are the rules. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. These are all consecutive. So if we think about it, it could be, let's actually write it out. It could be 1, 2, 3, 4, it could be 2, 3, 4, 5, or it could be 3, 4, 5, 6. 4 consecutive digits. And so which digits always appear? Well, the 3 and the 4 always appear, which makes sense, right? Because of the 6 digits, we have to remove 2 of them. So we could remove the top 2, we could remove the outer 2, or we could remove the bottom 2. That's it. And none of those touch the 3 and 4. So 3 and 4 are across here. So these are from 1, 2, 5, 6. These are the missing digits. Now it's not going to be 2, 5. It's going to be either 1, 2, 5, 6, or 1, 6. There's no good way to mark that, so I'm not going to. We also know that these 2 digits, notice this region here, I'll mark that green. These 2 digits need to appear in green somewhere, but they can't repeat in the column. So these 2 digits actually go here. So instead of marking this region green, what I'm actually going to do is I'm going to mark these as green. So what we have here is the 2 extremes of our run of 4 digits are, one is double the other, because they have to go across this black dot. And so if we did 1, 2, 3, 4, 1 to 4 is not double. If we do 2, 3, 4, 5, 2 to 5 is not double. If we do 3, 4, 5, 6, 3 to 6 is double. So this goes either 3, 4, 5, 6 this way, or 3, 4, 5, 6 this way. And we know this is a 3, 6 pair. That's really neat. All right, now we don't need this green anymore. And so this is 1, 2. Okay, so now we know that this is the 1, 2. Oopsie, this is the 1, 2 that's missing for the call. Do we have anything else like that? We have this ratio and this ratio. So we know that these 2 cells, I'll just use green again, they can't go here, so they need to go in these 2. Which means we can't involve the 5, because you can't ever put a 5 on a black dot. If you try to put a 5 on a black dot, you can half it to 2.5, can't do that. Double it to 10, definitely can't do that. So can't put a 5. So there's no 5 on here, which means there's no 6 on here. So these are from 1, 2, 3, 4, for what it's worth. Okay, so I was wondering how this worked. I think this has to be a 2. At least it can't be a 3, right? Because this digit is going to end up on one of these ratios. So whatever they go with, whatever this digit goes with, it's going to be here, and then there's going to be another digit it has to go with, like here or here. Let's just say it was here. Let's say this digit goes here, right? Let's just pretend. Then, like, let's say this was a 3. Let me just show you why 3 doesn't work. This was a 3. This ends up 6, because 6 is the only digit that can go 3 across the black dot. But then this is also 6. So that's not going to work. And we know that these 2 digits do end up here. So the conclusion is this is not a 3, which means this can't be a 4. Now, could this be a 3? I think it could. But yeah, this is from the 1, 2, 4, which means it goes with a 1, 2, 4. And so between these cells, 1, 2, 4 are gone. I feel like this has to be a 2. Yeah, it doesn't work for 1 or 4 for the same reason. If this was a 1, we end up with a 1 somewhere. That has to go with 2 here and 2 here. It doesn't work. So this is the 2. We know one of these is a 2. It goes with a 1-4. And then the other 1-4 isn't going to be here, right? It's going to be the other 1-4 that it goes with is going to be in one of these 2 cells, the one that goes with the 2. And then the other one's a 6. So this is 1-4-6. And then the 5 ends up down here. And actually, we could have placed the 5 right away because 5 can't go on a black dot. That might have helped a little bit, but this was fun. And so this has to be the 3 because one of these has to be the 3. And we get a 3 in the corner, deet deet dooting. And I don't think I need these greens anymore. All right, this 2 does look over, giving us the 1, which gives us the 4. So now this is a 1-6 pair. And we know the 1 goes with 2 and the 6 goes with 3. This 1 gives us the 2. This 3 gives us 6 and 3. All right, let's just fill these pairs here. We need a 5-6 here, and we need a 1-4 here. We do need... Yeah, this black dot here can't be 3-6, or we'd have too many 3-6s in this row. Look how many we'd have. 3 of them. That's bad. So this is from 1-2-4, and it definitely includes a 2, which can't go here because of this 2 here. So that's our 2. And then this can't be a 4 either, so that's a 1. That 2 gives us 3-6, which gives us 1-2. This 3 gives us a 6. 6 goes with 5, 4, 3. All right. This is 6 and 5. This is 4 and 1. All right. Now I think we just got to plonk digits, to be honest. The rest of this row is 4, 5. Not resolved yet. This region has to finish with a 4 and with a 4, and this region finishes with a 3. So this is a pair as well. This is 1, 2. This 2 tells us the order. We get the 1 and the 2. Okay. What do we have here? How about these verticals? We need a 3, 5 here. This 3 tells us the order, 5 and 3. We need a 2, which goes here because of that 2, and we need a 6. And so now this is 5, 6. This 6 says that's 5, that's 6, giving us 4 and 5. We need 1 and 4, and we're done. Thanks, Emphyrio. This was a really neat demonstration of our kind of mini law of leftovers logic, if you want to call it that. But basically, the fact that these 2 had to be the same as these, and these 2 had to be the same as these, came very much in handy. I could have placed this 5 right at the start, and I didn't, but I don't think that really slowed me down at all. Cool. Well, I enjoyed it. Hope you did too. If you did, then why not leave a like, subscribe, and a kind comment below.